Morning, children. Good morning, all of you. Good morning. Welcome back. Welcome back to probability. Okay, so we are going to start our problems based on probability. Before that, probability of an event equal to number of favorable outcome, number of outcomes favorable to an event divided by total number of outcome. And we know that total probability of all possible outcome of an event is equal to 1. Probability of head plus probability of tail equal to 1. Sum of probabilities of all possible outcome is equal to 1. And probability of E plus probability of not E is equal to 1. Probability of E plus probability of not E is equal to 1. And we studied probability of a sure event is 1. Probability of an impossible event is 0. And probability of an event lies between 0 and 1. 0 less than or equal to probability of E less than or equal to 1. Now we are moving to our problems. Exercise questions. We will do the exercise questions first. Okay, all these first one contains 4 questions. All are important questions. So write first one, probability of an event E plus probability of an event not E is equal to, answer it, all of you. Right? First one, this one. In one, first question. Probability of an event E, probability of an event E plus probability of an event not E is equal to, Minha, 1. Yes, good. 1. Second one, probability of an event that cannot happen is, probability of an event that cannot happen is, Iva, cannot happen. Probability of an event that cannot happen. What was that event? 0. And such events are called what, Iva?
Impossible.
Impossible event. Such events are called impossible event. Impossible event. Elsa, probability of an event that is certain to happen is 1. Such an event is called
Sure event.
sure event. Sure event. Sure event. Now, sum of probabilities of all elementary events of an experiment is sum of probabilities of all elementary events of an experiment is, Navneet? Is sum of, fourth one, answer for the fourth one. Sum of the probabilities of all elementary events of an experiment is
1 equal to 1.
Is 1. It is 1. Sum of, we have explained, no, probability of H plus probability of T is 1. Probability of 1 plus 2 plus 3 plus etc. Probability of 6 is equal to 1. Sum of all the probabilities is equal to 1. Fifth one, the probability of an event is greater than or equal to dash and less than or equal to dash. That means probability of an event lies between which of the values, Gauri?
I know.
Yes, Visan.
0 and 1.
0 and 1. 0 and 1. Probability of an event is greater than or equal to 0, less than or equal to 1, lies between 0 and 1. These 4 questions are very important. We can expect 1 from these 5, not 4, 5. Okay. Now, second question, we will discuss the second question. Which of the following experiment have equally likely outcomes? Equally likely means having same chance to occur. Having same chance to occur. Which of the following? See, tossing a coin is an equally likely experiment. The outcomes are equally likely. Either head or tail, both having same chance. Throwing a die is an equally likely experiment. Outcomes are equally likely. Okay, at any cost. And we need to check here 4 experiments are given. Out of this 4, which are equally likely? Means their outcome will be, we cannot predict. Okay, that way. First question, a driver attempts to start a car. The car starts or does not start.
Start.
But the starting of a car depends on some other details. Because suppose that driver is myself, it won't start because I don't know driving. Okay, so it depends on some other things also. And suppose there is no petrol, it won't start. If that driver or the person who starts is a person who knows the driving, it will start. If it is petrol also there, so it has some other things to its result. Okay, so it is not an equally likely outcome. So we can't say it's an equally likely outcome. It is not a equally likely outcome. Not a equally likely outcome. Okay. A player attempts to shoot a basketball. He or she shoots or misses the shot. That also depends. A player is putting his ball to that basket, a basketball player. It depends where he stands. It depends his height. Okay. So there are many chances. It depends on some other data also. So it also not a equally likely outcome. Not a equally likely outcome. A trial is made to answer true or false questions.
Ma'am, do we need to explain that say a driver attempts to start a car, the car starts or does not start?
Okay, because it is not an equal. If the driver, if the person who tried to start is not a person who knows driving, it can't start. Or if there is no petrol, it can't start. That's why. If there is petrol, it won't start. So we can't say equally likely outcome. Okay. So it depends on some other data also. That's why we are saying it is not an equally likely outcome. Okay. A trial is made to answer a true or false question. The answer is right or wrong. Is that an equally likely outcome? Srihari. And a question. The options are right or wrong. Is that an
If they don't know if they didn't study, they will not get
okay? Suppose the person who don't know the answer. So whether he will mark either right or wrong. Anyway, two of them are sure. Okay, right or wrong will happen. Like like our head and tail. One thing will happen. It is sure. Okay. If a person knows the answer or does not know the answer, anyway, he has to mark any of either right or wrong, either head or tail. Okay. But whatever be the conditions. But in the case of car, if petrol is not there, it won't. It's sure. It won't start. That time we can't say either it will start or it will not. That we cannot say because there is no petrol. But in this case, whether the person knows the answer or does not know the answer, one will happen. Okay. Either true or false. Then a baby is born. It is a boy or girl. Sure. Either boy or girl at any cost. So
Ma'am.
these two are equally likely outcomes.
Ma'am.
Huh?
Ma'am, iron basket is in the waiting room.
Okay. Equally likely. Equally likely outcome. Both are equally likely outcomes. Now, third question. Tossing, why is tossing a coin considered as a fair way tossing a coin considered to be a fair way to deciding which term should get the ball at the beginning of the football game? Okay, in all the games, in all our games, we will use this tossing a coin to fix a thing. Why we are using? Because both the outcomes, getting head or tail, are equally likely. We use it because the outcomes are equally likely. Head or tail are equally likely outcome, which we cannot predict. Which we cannot predict. So why we are using? Because it is an equally likely event. Because it is an equally likely event. Equally likely event. Okay. Which of the following cannot be the probability of an event?
Negative 1.5.
Which one? Negative, because probability lies between 0 and 1. Probability lies between, it cannot be a negative. So answer is negative 1.5. Probability cannot be negative. Cannot be negative. 0 less than or equal to probability of an event less than or equal to 1. Okay. Question number 5. Probability of E equal to 0.05. What is the probability of not E? Probability of E equal to 0.05. Probability of not E. What is the formula? All of you write. Probability of E plus probability of not E is equal to 1. Probability of E is 0.05. So probability of not E is equal to
Ma'am,
1 minus 0.
1 minus 0.05, and it is equal to
9.
0.95.
ma'am, we
Zero.
can write the answer in the textbook now.
No, why you are writing? Because the textbook, or do you have space to write the formula and all? Write in your note. No space in textbook. So write in your note. Write the question and write the answers in your note.
Fill in the blanks, you want write.
Huh?
Fill in the blanks that.
Filling the blanks. Okay, filling the blanks you can write. But you must make sure that you are passing through those pages during the exam time. Okay, go through the text also. Okay, write 6th one. All of you completed 5th one. Can I move to 6th?
1 minute. Yes, ma'am. Okay.
Over.
Oh.
Write 6th one. A bag contains lemon flavored candies only. Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavored candy? Dominic, what was the answer of that? A bag contains lemon flavored candies only. Only naranga mittais. Lemon flavored candies. That yellow color only. And Malini take one from that bag. And what is the probability that she will get an orange flavored candy? Orange candy. Dominic, what is the probability of getting orange candy from a bag containing lemon candies? Dominic. Delvin. What was the probability of getting an orange candy from a bag containing yellow candies?
1.
Huh? Louder.
1.
1. Delvin, the bag contains only yellow candies. And what is the probability of getting an orange candy from that bag?
0.
Zero. Yes, zero. That is, it is an example for which type of event it is? It is an example for
Impossible.
impossible event. Zero. Reason, it is an impossible event. From that bag, she won't get an orange candy because full of yellow candies. Zero. A lemon flavored candy. Probability of lemon candy. Probability of lemon candy. Ahlam. Probability of lemon colored. Huh? Louder, louder.
1.
One, because all candies is a sure event. It right in bracket. It is an example for sure event because all candies are lemon. All candies are lemon. So it is a sure event. Okay. Next question. Right. Question number 7. It is given that a group of 3 students. Probability of 2 students not having same birthday is 0.992. What is the probability that 2 students have the same birthday? Write the question. It is given that in a group of 3 students, probability of 2 students not having same birthdays 0.992. So probability of having their same birthday having or not having. So probability of not having same birthday plus probability of having same birthday equal to having same birthday, not having same birthday equal to
1.
Kshetra equal to
Ma'am, 8th one homework.
huh?
8th one.
No, wait. We are discussing 7th one. I will tell you later. Probability of not having same birthday plus probability of having same birthday equal to what? Even then not in E and not E. Kshetra. Isha. Raya.
1.
Equal to 1. Equal to 1. And not having is given. Not having is 0.992 plus probability of having birthday equal to 1. So probability of having same birthday equal to 1 minus 0.992. Find out how much it is. 1 minus 0.992 is equal to
0.008.
0.008.
008.
0.008. Eighth question. Do it. Eighth one. You can do. Try. A bag contains 3 red ball and 5 black ball. 3 red and 5 black. A ball is drawn at random from the bag. What is the probability that getting red? Not red. Probability of
And I saw the seventh one.
getting red is Alna Rose, probability of getting red ball. How many red balls? Alna. Alna, how many red balls?
And 3 red balls.
3 red balls. And total number of balls?
8.
Total number of
8. So 3 by 8. Not red. Not red means what was the other color?
Black.
Black. How many black?
5 black.
So 5 by total balls 8.
5 by 8.
3 by 8 or 5 by 8, or otherwise you can find probability of red plus probability of not red. That way also you can find is equal to 1. This is 3 by 8 plus probability of not red equal to 1. Now probability of not red equal to 1 minus 3 by 8. That also 5 by 8. This way also you can find any of the way. This is easy way. Because only two colored balls are there. If it is not red, it is black. Now try ninth one. Very simple questions. Make it fast. Very simple question. Ninth one. Box contains 5 red marbles, 8 white marbles, 4 green marbles. 1 marble is taken out of the box at random. What's the probability that the marble taken out will be? So there are red marbles 5, white 8, and green 4. Total marbles, total
17.
17 marbles. There are 17 marbles. Now write questions one by one. Probability of getting red. Probability of getting white. Probability of getting green. All videos are off. shown? Probability of red?
5 by 17.
5 by
17.
17. White?
8 by 17.
8 by
17.
17. And green?
13 by 17.
Green 13. Green. And not green. Okay, sir. Green is okay. 4 by green 4 by 70. Question is not green. Okay, good. Not green is not green means white and red. So white and red together 13. 13 by 17. 13 by 17. Or 4 by 7, 1 minus 4 by 17 also, that we also you will get 13 by 17. Question number 10. That also you can do. Write the question, do one by one. Simple questions.
Ma'am,
Hmm?
you can explain that ninth one. I was writing question. Question is very big.
Which one? Ninth one?
Uh,
Ninth, nothing is there. A box contains 3 colored balls. Red 5, white 8,
5 by
green
8.
4.
That
Okay.
no 5 by 8.
Yeah. Not 5 by 8. Total 17. Total there are 17 balls. So getting red ball 5 by 17. Getting white ball 8 by 17. Not green. Not green means other 2 colors. It is 13. 5 plus 8. Not green means other 2 colors. 5 plus 8. 13. So its probability is 13 by 17. Not green, green ball means either red or white. So 5 plus 8, 13. 13 by 17. Clear? A piggy bank contains 100, 150 rupee, 50 paise coins, 51 rupee coins, 22 rupee coins, 10, 5 rupee coins. So better you write all those details. Then we can easily write the answers. So first one, 50 paise coins. 50 paise coins, 100. Rupees 1 coins, 50. Rupees 2 coins, 20. Rupees 5 coins, 10. Okay. If it is equally likely that one of the coin will fall out when the bank is turned upside down. One is fall out from that bank.
No, we have to divide it by total now.
Yes. So total number of coins,
5. 5 and 5.
180.
total number of coins 100 plus 50 plus 20 plus 10, 180. 180. Now about our question. It will be the coin that fell down is a 50 rupee coin. Probability of 50 paise. 50 paise coin. How many 50 paise coins? 100. And
100.
total 180. We can simplify it to 2, 5, 5 by 9. Second question. Probability of, what was the question? Probability of it will not a 50 coin. Probability of it will not a 50 paise. That we can do 1 minus probability of it will 50 paise coin, like e plus not e. So it is 1 minus 5 by 9, 4 by 9. No, wait. 1 minus 5 by 9 minus. It will be 1 second. Let me check the answer. Question: what is the probability that it will not be a rupees 5 coin? Sorry. Will not be rupees 5. I thought it is 50. Okay.
Do we need to write the question?
Question 50, not 55. Okay. I thought it is 50. Probability of it will not. If it is will not 50 paise, that way we can do. It will not a rupees 5 coin. Okay. So how many remaining coins? If is
170.
170. Okay. Because only 10 coins are 5 rupee coin. So 170 by 180. 17 by 80. If the question is it will not a 50 paise coin, we will do 1 minus 4 by 5 by 9. Then it is 4 by 9. Okay. All are simple questions. Now,
Question do we need to write a very big lengthy question?
Right. 11th one. Write it. Gobi buys a fish from a shop for his aquarium. The shopkeeper takes out one fish at random from a tank containing 5 male fish, 8 female fish. What is the probability that the fish taken out is a male fish? Very simple. Answer it. Swati, what was the answer? It's a male fish. Swati,
5 by 13.
5 by 13. Okay, good. Because there are 5 male fish, total 13 fishes. So 5 by there are 5 fish, male fish, 5 male fish. So probability of getting a male fish is 5 by 30. 12. Question number 12. Do that 12th one.